Yeah, we can start. Can you please introduce yourself first?
Okay, so my name is Velijala Raju and I'm from Hyderabad. So I completed my graduation and I have total 4.5 years of experience in networking domain. In my previous role as a senior e-support officer, I worked with Cisco and Juniper products ASR 1K, ASR 19K, and Catalyst switches 3850 and 2960,
Mm-hmm.
and also Juniper products like MX240 router and EX4300 uh, device, and supporting for network enterprise level networks.
Mm-hmm.
And my main responsibilities are monitoring, troubleshooting, and configuring the network devices. And
Okay.
also, I used to handle the hardware level issues and protocol level issues.
Mm-hmm.
Hardware issues like if it is having any power supply failure, pantry failure, and line card issues or SFE port issues, and etc. And these are the issues we will get to our hardware. So by doing troubleshooting steps, we used to rectify the issues. And also protocol level issues. If we talk about that, OSPF and BGP protocols. So if it is stuck in any state, so by doing Wireshark analysis and by packet analysis and by using specific commands, we used to troubleshoot those protocols.
Mm-hmm.
And also I have hands-on experience on configuring static and default protocols, and also dynamic routing protocols like OSPF and BGP.
Mm-hmm.
And also I have worked on switching technologies like creating and maintaining VLAN topology, and also helped in designing LAN and WAN topologies. And also having additionally for troubleshooting purpose, I regularly used to use tools like ping, traceroute, and Wireshark analysis to identify and check the issues like network connectivity, packet loss, and latency,
Okay.
and also handle the instance high priority instance like P1 and P2 issues.
Mm-hmm.
And also was responsible for raising RMA for the hardware failures,
Mm-hmm.
and coordinated closely with the Cisco TAC and ISPs to for the fast and effective resolutions.
Okay.
And also having hands-on experience of ticketing and monitoring to like Op Manager and ServiceNow.
Okay.
And additionally worked with along with senior network engineers like L3, so which helped me to gain more knowledge for troubleshooting and escalation process.
Mm-hmm.
And also I was part in documenting process maintaining the IP address schemes, and also root cause analysis documents, and also
Mm-hmm.
supported the end devices with network related issues. Now
Okay.
I'm these are my roles and responsibilities, and right now I'm looking for the better opportunity in networking domain.
Okay.
That's it.
That's good. Are you still working, right?
No, actually, I have resigned in last migration, so right now I'm ready to join immediately. So
Okay.
I
Okay.
have
Okay. Sure. Sure. Yeah. You mentioned about to prepare some documents, right? Have you prepared any specific document related to any troubleshooting steps or RCS that you have provided?
So for high priority like critical issues like P1 and P2, so for one P1 issues we have created one document, the process like how after receiving the ticket, so how we have resolved that. So based on that troubleshooting process, we have mentioned like how the ticket has came, what are the troubleshooting steps we have processed,
Mm-hmm.
and which teams we have been contacted, and what is the closure of that incident.
Mm-hmm.
So based on that, we used to create the document.
Okay. Okay. Yeah. Let's go into a technical discussion. Okay. So, do you know different types of ops? What are different types of ops we have?
Different type of
ARP, ARPs,
ARP.
address resolution protocols.
Okay. Yeah, one is like normal ARP, and the another one is gracious ARP.
Mm-hmm.
The normal ARP, which we use, it is used to resolve. It is a layer two protocol, and it is used to resolve the IP address to MAC address.
Mm-hmm.
So when in a local area network, when we want to
Is it resolving IP address to the MAC address or?
no mapping, it maps the IP address to MAC address actually.
Mm-hmm.
It maps the IP address to MAC address.
Mm-hmm.
So in the networking domain, if you want to reach the specific destination, we need to know the destination IP and MAC address.
Mm.
So when we are using a ping, so as we know the destination IP address,
Mm.
but we need to know the MAC address as well.
Okay.
So ARP is a protocol which helps to find out the MAC address. So
Okay.
based on the PC will generate the ARP,
Mm.
and based on the ARP request, it will send the ARP request to
Mm-hmm.
find out the MAC address. So
Mm-hmm.
the destination IP will find out the respective IP address, and it will send it will give the ARP reply along with the MAC address.
Okay.
And in this species, they will also save the ARP table, like the PC. And if you take the two PCs, the PC will also save the ARP table, and the PC2 also save the ARP table before sending the ARP reply. So
Okay.
these are the general ARP we are using in the as a layer 2 protocol. And the gracious ARP is that to find out the duplicate IP addresses. Here
Mm-hmm.
in the sender IP and the like sender IP and the target IP will be the same.
Mm.
So to find out the duplicate IP, we use this gracious ARP.
Okay. Is that only one you know? Do you know about proxy or inverse
No,
R?
these two apps I
Oh,
know.
okay, okay. Do you know, okay, use case of gracious R where we can generally see this gracious R?
So we see in the VRRP
Okay.
like environment.
Okay.
So to the PCs will in that the gracious are be used to find out the duplicate addresses.
Mm-hmm.
As we have virtual MAC address,
Mm-hmm.
so then it is fine.
Yeah, that is one use case.
Yeah.
Have you seen anywhere in the DSCP?
No, no, not exactly.
I
I
think
didn't remember. I know.
if you have, yeah, okay, okay, that's fine. So it will also, we can also see that in the DSCP as well. Once the client gets IP address, so it will send a gracious up to find whether it is a duplicate IP address or not. That is
Okay,
also
okay.
one use case. Yeah,
Thanks for the information.
yeah, no issues. Can you briefly explain about trace route process? Let's take I have given a scenario R1, R2, R3, R4. R1 is connected to R2, R2 is connected to R3, R3 is connected to R4. Now I want to reach R1 to R4. So can you explain about the trace route process here?
Yes. So when we initiate the trace route from R1 to check we initiate the trace for the R4. So generally the trace route it uses the ICMP protocol.
Mm-hmm.
So and also it uses the three UDP packets.
Mm-hmm.
And by using the ICMP tool, so we can check with the help of ICMP we can trace the route from source to the destination. So and we can check the number of hops and relative respective IP address and the round trip time from the source to the destination.
Mm-hmm.
And here we can see the TTL value.
Mm-hmm.
So the PC, the like router one will with the help of the ICMP, and in the IP header we can see the TTL value actually.
Mm.
The TTL will be increased. So when the with respect to the router one to router two.
Mm-hmm.
So when the initially the TTL will be one. So when
Mm.
we move to the router two, the TTL so in our networking environment, whenever the TTL value is moving to one router to another router, it will be decreased as
Mm.
one. So
Mm.
if it is one, it will minus as one. So it will
Mm.
become zero.
Mm.
So then router 2 will initiate like time exceeded ICMP message.
Mm.
So based on that, we can know router 1 will know the router 2 is having the next hop.
Okay.
So based on that, it will increases router 3 and router 4. The TTL will be increased, and based on that, and also it will decreased whenever it is crossing to the next hop.
Mm.
So based on that, we'll get to know the IP address of the R3 and R4.
Mm.
So with respect of these fields TTL value, so we'll get to know the entire hops from R1 to R4.
Okay, okay, that's good. So just briefly explain about DSCP process and also how packet flows whenever both DSCP servers and client are in same subnet or same network.
Okay, you want to explain complete DHCP process?
Yes.
Okay. So DHCP, it's a dynamic host configuration protocol. It is used to automatically assign the IP address to the network devices.
Mm-hmm.
And suppose if you take a PC client, and So in the if you PC want to get the IP address, so if the PC connect to the network, so it needs the IP address to connect with the to get communication with the internet. So if you have DHCP configured, server configured, the PC from the PC, the client, it will actually the DHCP works on the process of DORA process.
Mm-hmm.
DORA is nothing but discover, offer, request, and acknowledge.
Mm-hmm.
So these four messages is helpful to find out the IP address.
Mm-hmm.
And the PC first initiate the discover message to the DHCP client. So here we can see the Ethernet header and also the IP fields. In the Ethernet header, we can see the client MAC address as a source MAC, and also the destination MAC is the will be the broadcast as we don't know. So to
Mm-hmm.
find out the DHCP server, so the destination MAC will be the FF like
Mm-hmm.
FFF and FFFF, and source IP is the client IP. So source IP we need to get from the DHCP server. So initially it will be as a 0.0.0.0, and the destination IP will be the as it is broadcasting 255.255.255.255.
Yeah.
And also we having one more field as DHCP payload. Here we can see the client MAC address as a like PC MAC address.
Mm-hmm.
So here like first the PC will initiate as a like offer like sorry discover message to the DHCP broadcast,
Mm-hmm.
and the DHCP server which is enabled. So it will accept that DHCP discover message and sees that discover message, and it will reply. It will give offer message. In that offer message, the respective fields are like the same Ethernet header fields, like the source will be the source MAC address will be the DHCP server MAC address, and the destination MAC will be the broadcast, and the source IP will be the DHCP server IP, and the destination uh, IP will be the like it is a broadcast 255.255.255. And also the DHCP server will also give some we can see in the here we can see the DHCP options as well.
Mm-hmm.
Subnet mask, the DHCP option 1, and the
Mm-hmm.
router is the DHCP option 3,
Mm-hmm.
and the DNS is the DHCP option 6. And
Mm-hmm.
also we can see the IP lease time, which is DHCP option 51. And also one more option, DHCP option 54, which is the DHCP server identifier.
We have
And
one
also
more, one more, right?
DHCP,
DSCP option 53.
53 is the message type.
Oh,
Yeah.
yeah, yeah. Oh.
DHCP message type, we can see the like it is the offer message. In the message type, we can see that it is an offer.
Mm-hmm.
And the offer message is received by the PC. So and now client the PC will request for the offer message, which is given by the DHCP client. So in this offer in this sorry it will request in the client will the request for the IP address. In this request message, we can see the fields like Ethernet header, same as the
Mm-hmm.
discover, like it will broadcast as a destination MAC address, and the source MAC address is the PC one, and the
Mm-hmm.
source IP will be the 0.002,
Mm-hmm.
0.0.0.0, and the destination IP address will be the
Mm-hmm.
broadcast.
Yeah.
And also we can see the here the one more option it is added, that 50, which is the IP address, the IP address which we are requesting. And also
Requested IP address.
requested IP address, sorry, requested IP address, and also DHCP server identifier, which is 54.
Mm-hmm.
Also DHCP message type, which is a requested message,
Okay.
and the server will receive this requested message, and now the server will give the acknowledge as the client is requesting. In
Mm-hmm.
this acknowledge, we can see the header as the broadcast, the destination MAC will be the broadcast, and the source MAC will be the client MAC, and the source IP will be the DHCP server IP, and the
Mm-hmm.
destination IP will be the like 0.0.0.
Mm-hmm.
And in the DHCP payload, we can see your IP, like our IP, that the DHCP which is offering, and also the client MAC will be the destination IP. Client MAC will be the PCCI, the destination MAC IP, and we can see the same options as we can see in the offer message,
Mm-hmm.
like subnet mask router, which
Mm-hmm.
is 1, and router is 3, and DNS is 6, and
Mm-hmm.
also 51 is lease time, and 53 is the message type, which is the last acknowledged message, and 54 is the DHCP server identifier.
No.
Now all the four messages has been happened. So
Hmm.
now the client will get the IP address.
Hmm.
Now it can communicate, it can access the internet. So
Hmm.
whenever if the IP address lease time has been finished, so it can also connect with the server with the help of two options like 58 and 59, which is a renewal time value and the rebinding time value.
Hmm.
So based on that, it can renewal the IP address
Yeah,
lease time. Yeah.
see, once Doro process completes, the client will send a gracious server. Okay. After offering, whenever the DHCP server offer IP address, right? Not offer,
Okay.
after acknowledge message. If you take
Okay.
the packet capture, you can see once Doro process completed, it will send a gracious server to the network, into the network.
Okay. I missed on that. I'll check once
Yeah,
again
yeah,
now.
yeah. Not, no. Yeah. Which protocol DHCP will use?
Sorry, I missed on that. DHCP uses like UDP protocol,
Uh,
and like it uses source port as 68, and the destination port will be the 67. So based
okay.
on the message type, the source and
Uh,
destination port will
they'll,
be changed.
yeah,
Yeah.
okay, okay. Yeah, now, okay. I have a router, okay. I have a router, a switch, and a PC. So I have router, switch, and PC. Out of these three, which one will generate broadcast message?
Switch will do the broadcast.
No, no, I'm asking who will generate broadcast message or broadcast packet.
Okay, PC, switch, and router. So in these three, we will generate the broadcast packet message.
Broadcast message or broadcast packet.
Just give me a minute.
Yeah, take your time.
Like as we mentioned, PC and switches and routers. As PC itself will not do broadcast, as if you whenever it is requesting for the when we are using the
No,
ping.
I'm asking about generating the broadcast message. Who will generate broadcast message? So if you think about ARP and DSAV process, those are
Okay,
all broadcast
PC
message.
will generate the
That's it.
yeah.
Yeah, whenever you think about broadcast message, the PCs or routers will
Yeah,
generate.
okay, yeah, yeah.
But
Yeah, L3 devices as it want to
mm,
the IP. So L3
mm,
devices as PC and servers, it will do the broadcast message.
but the switch will not generate
Yeah,
a broadcast. It will process the broadcast messages.
yeah, yeah. Sorry, I confused in that two statements.
Yeah, that's how the interview questions will be. They will be mostly confusing. So you have to stick with your answers. Yeah.
Sure, sure. I'll definitely work on
So
this.
if your client and DHCP server in different network, which what how it will send the messages. If your client, okay, if your client and DHCP server in the same subnet, that should be fine. So if the DHCP server and the client are in different subnets or different networks, how the messages Dora process will happen between client and the server? Have you heard about DHCP relay agent?
No, no, I have not had that.
Okay, okay,
I
no
missed,
issues,
might I missed on that.
no issues. So whenever you have DHCP client and server in different networks, you need to have DHCP relay agent.
Okay.
So in order to process your broadcast messages, so the routers will not process broadcast message, right?
Yes. Yeah.
Will not send broadcast message from one network to another network. So whatever the PCs is generating, those are broadcast messages, but the routers will not process. So in that case, we have to enable DHCP relay agent on the router so that that relay agent will be able to process your broadcast messages.
Okay. Okay. I got it.
Okay. And do you know about VTP?
Yes. Yeah. It's like
Yeah. What are the modes that are available in VTP?
So we can see three modes like VTP server client mode and VTP server mode and VTP transparent mode.
Which one is default mode? Out of these three, which one is default mode?
I guess like transparent mode, which will send the traffic from server client to
No, no,
server.
no, I'm asking about if you take this, if you take okay hundreds of switches, one mode will be always be default. So what is that mode?
That's
Out of server, client, and transfer mode, one mode will be always be default on the switches.
that is like, you're asking VLAN default VLAN.
No, no, no,
No,
VTP only, VTP modes. Basically, all the switches always be in the server mode. Okay, whatever the
yes, we
switches. Mm,
by with the help of VTP advertisements, we will like
whatever the switches that you want to made it as a client, you have to configure those switches at the client.
I am not able to recollect right now.
Okay, okay, sure, sure. Just go through that once. So, do you
Sure.
know about revision number?
Sorry, revision?
Revision number in VTP.
No.
Okay, okay.
Uh,
Could you explain the VTP process once?
okay. Actually, VTP it's like VLAN trunking protocol.
Mm-hmm.
So actually in VDP, so if you have like more than like if you have multiple switches,
Mm-hmm.
so we can't able to configure all the switches manually.
Mm-hmm.
So we will elect one switch as a VTP server. So
Mm-hmm.
if you do any changes and other switches will be as a VTP clients. So if you do any changes in the VTP server switch, so the changes will be automatically happen in the VTP server switches.
Mm-hmm.
And also we have to be enable the trunk so to enable the communication between the VLANs.
Mm-hmm.
So by based on VTP advertisements, the process will be happen. The changes will be happen.
Okay, then how the clients will update those changes that we have made on the servers?
So with the help of transparent mode,
Mm.
the communication will happen.
Communication will happen and they will update the
Update
what? Mm.
like changes and
Mm.
add and like new images.
So whenever there is an update message going on between the clients, so there will be an revision number. Okay, just
Okay, that
verify that revision number how it happen updates on the
I'll
clients.
do that after the interview.
Ah, yes. So what is the main purpose of the VLAN?
VLAN.
Ah, yeah.
Okay, so as we know, in switch, so all the ports will be in default to VLAN.
Uh-huh.
So in VLAN, the when we are sending in a broadcast, when we are sending a so in VLAN, the broadcast message will be sent to the all ports by default.
Hmm.
In as a switch is having like number of ports, so we can segment those ports as a different VLANs.
Mm-hmm.
So it need not to be in one physical location. It can be any physical location. So
Mm-hmm.
based on that ports and based on our requirement, we can create like few ports as a VLAN one and a few VLAN two or VLAN three. So
Mm-hmm.
based on the ports, we can segment the large broadcast domain into the smaller
Mm-hmm.
broadcast domains.
What is the advantage of creating VLANs?
So the advantage of creating VLAN is that like we can like it helps for the scalability and it can so the broadcast is domain is divided as the small broadcast domain. So
Mm-hmm.
whenever in the specific VLANs, the information only pass to the same VLANs only. It will not pass to it will not communicate with the other VLANs. So
Mm-hmm.
it can improve the performance and also we can decrease the memory and
Mm-hmm.
also scalability also it will useful for the scalability.
Okay, okay. So I will give one scenario now. Okay. So I have two switches and two PCs. Okay. Switch
Okay.
one is connected to switch two. Okay. And PC
Okay.
one is connected to switch one and PC two is connected to switch two. Okay.
Okay.
Now what
Okay.
happened, right? All the switch one and PC one, whatever the PC one is connected to switch one is an VLAN 10. Okay. And
Okay.
the switch 2 and PC2 which is connected to the switch 2 is in VLAN 20. All ports,
Okay.
okay, all the ports which are connected, okay, are in access ports. All are access ports only. Okay.
Okay.
Access ports in sense PC1 which is connected to switch 1, right, that is also access port. and
Yeah.
the ports that are connected between switch 1 and switch 2 also access port, and
Okay.
the PC2 which is connected to switch 2 also access port. Okay, now
Okay.
just I am pinging from PC1 to PC2. Will it ping, or will it not ping?
Just give me a minute.
Yeah, you understood the scenario, right?
Yeah, understood scenario. Just I want to recall.
Yeah, yeah, go ahead. Yeah, just
Yeah, it will like when we initiate the ping from PC1 to PC2, it will ping actually.
okay. How it will ping? Just can you explain the process how it will?
So actually, so when we initiate the ping from the PC1,
Mm-hmm.
so it will generate a ICMP echo request.
Mm-hmm.
So from PC, as it is a VLAN, it will tag the VLAN. It will get the tag by the in the PC
Mm-hmm.
itself. And when we go to the switch in the access port in the switch, so
Mm-hmm.
when it is sending out going to the outgoing traffic to the another switch, it will untag the VLAN, and it will generally only it will go the empty ICMP packet.
Mm-hmm.
And in the switch 2, it will again tag the like it will go through the tagging process, and again
Mm-hmm.
it will untag there. So based on this, we can ping the
Mm-hmm.
different places.
Okay, okay, good. And which routing protocol are you well aware of? Which routing
Like
protocol?
USPF and BGP.
BGP. Oh, okay. So what is how many states are there in OSPF?
There are 7 states in the OSPF, like
Mm,
down state, init state, two-way state,
mm,
extract, exchange, loading, and full state.
what will happen in the two-way state?
In the two-way state, actually the neighbors will discover.
Mm,
So we can check the neighbors by giving show IP OSPF neighbors command. And in the two-way state, as DRBDR elections will happen.
mm-hmm.
So these elections will happen because to prevent the loops in the OSPF domain.
How
Uh,
they will form neighborship?
Neighborship will be formed like as in the downstate. So one if you consider two routers like router 1 and router 2,
Mm,
whenever if you configure the OSPF,
mm,
so the first is the downstate. So
mm,
here the hello packets will be exchanged from router 1 to router 2.
mm,
So with the help of OSPF header fields and the like hello packet fields,
mm,
and the router so it will move to the init state. In init state, the router will check those packets like OSPF header and hello packet fields.
mm,
If all the packet fields are matched with the along with the router 1 and router 2,
mm,
so the router ID should be the unique,
mm,
and the router in init state, the router 2 will all the fields are matched, so router will 2 will send the hello packet
mm,
with the respective of the active neighbor field along with the router ID.
mm,
And once router one will receive the R2 hello packet, and router will also initiate the hello packet with the help of active neighbor field along with the router ID.
mm,
Then it will move to the two-way state. Here, all the packet alarm fields are matched. So
mm.
now here the neighbors will be formed in the two-way state.
Okay, okay.
Discover. I will discover. Yeah.
Okay, you mentioned about router ID, right? How that router ID will be elected? There is certain process, right? If you have, okay, I have loopback address, I have configured manual router ID, and I have also configured some IP address of the interfaces. Out of all these, the router select which router ID is?
So
Which IP has router ID?
first it will check the manual IP address.
Mm,
Then again it will go for the loopback address, highest loopback address,
mm,
and the interface IP address.
First it will select whatever the manual router
Mm.
ID we have connected. Yeah, okay. Then yeah, see here I have configured two routers with a OSPF, but my OSPF neighborship is not forming. Okay, so how you'll troubleshoot this scenario?
As neighborship is form not formed, so we can check by giving command OSPF show IP OSPF neighbors. So there we can see the status in which state it has been stuck.
Mm-hmm.
So if it is so based on this status, we can verify which status has been stuck, and also we can check. We have to see that as neighborship is not formed into a state. Like just give me a minute. I think.
Yeah, yeah,
So you are saying that like once again, just to repeat the question, like.
yeah. You understand the scenario, right? I have two routers, R1 and R2. I have
Mhm.
directly connected.
Mhm.
Now I have configured OSPF everything in the R1 and also R2, but OSPF neighborship is not forming on both routers. So what may be the issue and
Okay.
how you will troubleshoot this?
Okay. So as OSPF neighbor is not forming, so we can see that as hello packet is generated from R1 to R2. So whenever the fields are mismatched, if the OSPF header and the packet hello packet fields are mismatched,
Mm-hmm.
like if
What are those fields in the?
fields means like if it is the area type is it should be the if it is area 0, it
Mm,
should be the same area,
okay.
and the router ID should not be the same. It should be
Mm,
the different.
okay.
And if you go to the packet fields, the subnet should be the same. It should
Mm,
not be the different subnets,
mm,
I guess. And also, router, and also, yeah, that's it. I think these are the important fields we need to check to match with.
and also you will be having hello timers, date interval,
Yeah, auto timer and data interval
and
timers.
also you will be having authentication type as well, right?
Type and application data also.
Mm.
There is the OSPF header.
But first you need to go with okay. If you want to troubleshoot, you have to go with one by one, right?
Yes,
So
yes.
it is directly connected. Maybe some issues with the port or some issues with the
Yeah,
cable.
physical cable also.
Yeah,
Yeah, interface also cable.
interface also you have to do a
Yes.
troubleshoot on this level. Whatever you said correct, but you are missing these things.
Yeah.
Okay, and see, I have configured OSPF on routers, okay, but I see that OSPF adjacency is not found. I see that all the routers are in two-way state. So, what may be the reason if the router stuck in two-way state?
So if it is stuck in two-way state, so as we see, DRBRDR elections happen in the two-way state
Mm,
based on the highest router priority. So if
mm,
the priority will be equal, so we'll go with the highest router ID.
mm,
So whenever the priority will be the zero,
mm,
so then the elections will not happen. So
mm.
based on that, it will stuck in the two-way state.
Okay, that is one reason. Is there any other reason? You have verified, okay, you have verified priority. Priority is
Yes.
not same. So, is
Yeah.
there any
Okay.
other reason?
So if router ID is like if you misconfigured or wrongly configured the router ID,
Hmm.
so it will having both the router ID will be the same. So it
Hmm.
will not able to like identify the which
Hmm.
like highest router ID. So
Hmm.
based on that, it will
Okay.
not elect the election will not happen.
Okay. I have verified the router ID is also not same. It is unique. Then what may be the other reason?
So as no, no, so if like might if OSPF. Any like in physical connectivity we need to check, and the interface also we need to check.
Interface physical connectivity. That's not problem here.
Okay. So I think these two fields we need to verify, and
Uh,
next time
that
not able to recollect.
yeah, that's fine. These are the two reasons that we can tell, but will be also see the two-way state on DR other routers in the broadcast. Okay, in the broadcast domain, you are going to elect DR BDR, right? So
Yes.
only the routers which are DR other, okay,
Okay.
that will be always in two-way state because
Okay.
it will only form adjacency between DR and BDR, and it will not form adjacency between DR other routers.
Yeah. Yeah. Yes.
So DR other routers will always be in two-way state, and it will form only adjacency between DR and BDR. That is not an issue. That is an expected behavior. But okay,
Okay, okay. I'll just
yeah,
check
yeah,
on this.
no issues, no issues. And how many LSA types are there?
Total, we have 11 LSA types.
Mm-hmm.
And if you like, if you go on the LSAs, the type one is the router LSA generated by the each router in the OSPF domain,
Mm-hmm.
and type two will be generated by the DR
Mm-hmm.
and designated router, and type three is generated by ABR,
Mm-hmm.
and type four is also generated by ABR, and type five is generated by ASBR,
Mm-hmm.
and type and we'll see the type seven, which is generated by the uh, like type 7 is generated by the ASBR,
Mm-hmm.
and which is the type 1 we call is a router LSA, and then type 2 is LSA type 2 is a network LSA, network summary LSA, and type 3 is the summary LSA, and type 4 is the um, sorry, type summary LSA, and type 4 is the sorry, I'll just once again I'll come. Type one is the router LSA, type two is the network LSA,
Mm-hmm.
and type three is the summary LSA.
Mm-hmm.
Type four is the ASBR summary LSA, and type five is the external LSA,
Mm-hmm.
and type seven is the NSSA external LSA.
Okay. So, do you know about stub area, total stub area?
Yeah.
So, I have area 1 is connected to area 0, and also area 0 is connected to area 2. And I
Okay.
have configured everything OSPF and everything formed. Okay. Now I have configured area 1 as an stubby area. Okay. So, if you
Okay.
configured one area stubby area, what type of LSAs you can see in the stub area?
So if we configured stub area in the area one, so it will actually the stub area will do that. It will stop. It will stop getting the type file LSS.
Mm,
It will stop the type LSS. As if we stop the type LSS, we can also not see the type 4 LSS as well.
mm,
We can see we will not see these both type 5 and type 4 LSS.
mm,
And as we can only get the default route injected by the ABR router. So
mm.
based on that, we can communicate and we can get the LSS.
Okay. What is NSSA?
So NSSA, like if you in our SPF domain in that area, the so if it is connected with two routers, which is like ABR router and ASBR router,
Mm,
the NSSA is nothing but so the ASBR router which is connected with the OSPF domain and the other routing protocol which is like BGP.
mm,
So it will the SBR will allow the external LSS of like type 7 LSS.
mm,
So in that area, it will advertise as a Type 7 LSA.
mm,
To complete other OSPF areas, it will the ABR router will convert the Type 7 LSA as a Type 5 LSS,
mm.
and it will advertise the LSS as Type 5.
Okay, okay.
Yeah,
The ABR is going to convert Type 7 LSA into Type.
it's Type 5.
Okay, okay, that's good. So if both OSPF routers are stuck in X state, what may be the reason?
In extract state.
What will happen in the X state first?
In extract state, actually, deep database synchronization will happen.
Mm,
So this happens based on the master and slave elections.
mm,
So master and slave election based on the highest router ID.
mm,
So and the highest router ID will be the master, and lowest router ID will be the slave. So
mm,
here the slave will start sending the type 1 LSS based on the DBD packet fields.
mm,
So if it is stuck in the extract state, yeah, if MTU is mismatched, like one
mm,
router is having like 1500 MTU,
mm,
and the another router is having 1400 MTU. So
mm,
the higher one will receive this MTU as it is as 1400.
mm,
The lower one will not accept this 1500
mm.
MTU. So based on that, it will stuck in the extract state.
Okay. And what you will do in that case?
So here we can by like giving the same MTUs in that
Mm,
if it is less in the router too, so we can change the MTU as the 1500,
mm,
and also mm, we can do the MTU path discovery. Based on
mm,
that,
mm.
we can check and we can
Okay,
change that.
okay, okay. That's fine. That's fine. And you mentioned about BGP as well, right? So, do you
Yes.
know about how loop avoidance will happen in IBGP?
Yes, in IBGP, based on the split horizon rule,
Hmm.
so it will avoid the loops. So in split horizon rule, the IBGP router do not advertise the router which is learned from do not advertise the IBGP router from one IBGP peer to the another IBGP peer.
Hmm.
So if it is not advertising the from one IBGP to another IBGP router, so the loops will not occur. So based on the split origin rule, it will prevent the loops in IBGP.
Okay, now I will give one scenario. Okay, we have three routers R1, R2, R3. R1 is connected to R2, which is in AS100. Okay, R1, R2 is in AS100,
Okay.
and R2 is connected to R3 again. Okay, and
R2 is connected to R3.
uh,
Okay.
R3
Okay.
is in AS200. Okay,
Okay. Different days. Mhm.
different AS. R1, R2, AS100, R3 is in different AS, which is AS200. Now I have a route, okay, 1.1.1 in R3. Okay, so I am advertising that route to R2, which is in AS100. Will that route advertise to the will that route advertise to R1?
Mm. And can I get know the like it is the router one router two in the 100 AS and the router
Mm,
three is in different AS.
mm.
So it is advertising to the R1. So whether it is advertised or not, you are asking, right? That's it.
R3 we have an route in, okay,
Mm.
there is an external route 1.1.1.1 on
Okay.
R3. Okay,
Mm-hmm.
R3 will forward this route to R2. That 1.1 router will forward that to the R2. Will that route will make also advertise to
So R1.
R1 or not?
Just give me a minute.
Yeah, yeah, no.
It will not advertise. Actually, it is so
Why?
in
Why it will not advertise?
so in external like in EBGP external EBGP we can learn the routes like from one external BGP to another external BGP. In internal from external to internal, so the in the 100 AS the router should be in the all the router should be in the both the routers should be in the IBGP network. IBGP should be configured. Then only it will advertise. If not, it will not advertise the external IP to the internal.
No, your answer is not correct. Actually, it will advertise because whatever the route learned from the external, okay, external BGP, it will advertise to its neighbors in the IBGP.
Okay.
That is a thumb rule we have in BGP. Okay, whenever you have learned, okay, R1 is learned external route from R3, it will advertise to its neighbors in IBGP.
Okay.
In both, if a route learned in the from the IBGP peer, it will not advertise.
Okay, from IBGP to external, it will not advertise.
No, no. Actually, what I'm saying is, whatever the route learned from the IBGP, it will not advertise to other
Okay,
IBGP feeds. But
okay.
whenever R2 learned route from EBGP, it will
IBGP will,
advertise to its IBGP feeds.
okay, I just confused this split horizontal and this
Mm, yeah,
topology.
yeah. So how loops will avoid in EBGP?
In a BGP, based on the AS path prepend, it will avoid. Actually, if a BGP route receives a route,
Mm,
it will check its own AS is there on the AS path or not. If we find its own AS, it will drop that route.
mhm.
Then the loop will not occur.
Okay, I will give one more scenario. Okay, I
Mhm.
have three routers, same. Okay, R1, R2, R3. So R1 is in 100 AS. Okay, R2 is in 200 AS, and
Okay.
again R3 is in AS 100. Okay,
Okay.
Now I'm advertising one route from R1 to R2. Okay.
Like one small like three routers in the three different A's.
No. R1 is in
R
100,
R2
R2
in
is in 200, again
R3
R3 is in 100.
100.
But
Okay.
R1 and R2 is not directly connected. Okay.
R1 and R3s.
Not directly connected. It is R1, R2, R3 is linearly connected. R1
Yes.
to R2, R2 to R3. That's it.
Okay. Okay.
R1 is 100, R2 is in 200, R3 is again in 100. Okay.
Okay. Okay.
Now I'm advertising route from R1 to R2, and again R2 is going to advertise that route to the R3. Okay. Will R3
Mhm.
will include that route in the routing table?
Just give me a minute.
Oh yeah.
Actually, if we see the router one is AS100.
Hmm.
So when we advertise to router 2, it is a different AS.
Hmm.
The like both the AS will be added in the AS path like 100 and 200.
Hmm.
So when it is going to the router 3,
Hmm.
the AS will be added. If you see the router 3 is in the AS100,
Hmm.
that is just it will be actually it will advertise because the router 3 is it
R2
will
will
not.
advertise, but will it R3 will it route will include it in the routing table or not?
Okay. I think it's based on the protocols. It will include it. If it is,
Mm-hmm. I thought you got the
just give me.
point, but you are confusing.
Yeah, I'm confused. Yeah. It will advertise because it will add in the table routing table.
So if the one route is need to add in the routing table, it should not be from the same AS, right? Because I told you R1 is
Yes,
in
yes.
100,
The
R2
routers.
is in 200, R3 is again in 100. Okay, whenever you are receiving a route from R2 to R3,
Mhm.
what exactly will be having in the AS will be having 200 and 100, right?
Yes, yes.
So if this route goes into the R3, it will check what it will check whether it is
Only
coming
will.
from the same AS or not. Okay,
Yeah, yeah.
so it will see its own AS number, right? Whenever
But
you
okay,
whenever you are learning a route from the EBGP, obviously it is going to check how the loops will avoid. Then it is going to check AS
yes.
path, right? So it sees
No,
its own AS number and it will discard that route. It won't install.
actually, I was confused that only the router which is initiating that advertising that router, so it will check only that own OAS. I'm not. I have confused that router 3 is also in the 100. So this is the router one
Router 3 is also AS100,
is
right?
100 only.
So if you want to install the route in the routing table, it should not be from the same AS.
Same AS,
That's
yeah.
how it will avoid the loops, right?
I'm thinking that
So
only router one will check that.
mm,
Actually, both whichever routers in the same AS, it will not.
okay.
I
If
was
it's
just confused.
uh, see here, now R3 will not install that route in the routing table, right? So if you want to, okay, even though we are receiving the route from the same AS, if you want to install that route in the routing table, what we can do on the R3? Do you know about the concept of allow AS in?
Hello, ASN.
Mm. In BGP, we have a concept of allow AS in and AS override. Okay, so whatever the scenario I told you, right? Whenever you are receiving the route from same AS number, if you want to install that route in that routing protocol, you have to configure allow AS in. Okay, so even though the route received from the same AS number, it will allow to install that in the routing table. So that will
This
allow AS in will do on the route R3. And if we don't have any access to the R3, we can do also, we can do that same thing on also R2. Okay, R2 you can do AS override. Okay, what it will do is
okay.
it will override the AS100 with its own AS number, and it will send only with AS 200 200 like that.
This
So
feature I am not aware of
okay,
it.
okay. If you are not aware, just I'm letting you know. Okay, there will
Sure,
be a
sure.
concept of allow AS in and allow AS override. AS override. You can just verify that thing. Okay.
I'll definitely do check it on.
Okay, okay. And do you know about BGP attributes?
Yes. So in BGP attributes, we have like two well-known and optional attributes.
Mm-hmm.
In well-known, we can see two types, like a well-known mandatory and well-known optional.
Mm-hmm.
So well-known discretionary. In
Mm-hmm.
well-known mandatory, we can see like three fields like next hop, AS path, and origin values.
Mm-hmm.
And in well-known discretionary, we can see that local preference and atomic aggregator.
Mm-hmm.
And in in optional attributes, like we can see transitive and non-transitive.
Mm-hmm.
In transitive, we can see that aggregator and also uh, aggregator and community.
Mm-hmm.
In community, we can see the local AS,
Mm-hmm.
one of the field, and in non-transitive, we can see the MED value, cluster ID.
Mm-hmm.
That's not able to recall it.
Okay, okay. You will be having origin as well, right?
Yeah, yeah. Origin I have mentioned in the
Okay.
non-mandatory.
And what thing? What else you have missed? You missed
In
about weight, I
in
think. Weight or next also.
next stop I mentioned
Hmm.
wait. Actually, wait.
Oh, weight is in Cisco, but you cannot see anywhere apart from Cisco.
Hmm.
Okay, see here, if I want to manipulate the route, okay, if I want to manipulate the routes that are incoming routes, so which attributes we can mostly use here?
For incoming, we can use one. Just give me a minute.
No, yeah.
Uh, outgoing.
If I want to manipulate
I
the routes
remember,
that are incoming routes, okay.
I remember, but I'm not able to recall. Just give me a minute. Just I'm just confused for the incoming and outgoing.
Yeah,
So
yeah, no issue, no issue.
outgoing, we'll use like local preference and wait. For
That
incoming, like like AS path.
yes path,
Prepend, not prepend. Like,
yes path prepend, and one more,
yeah, one more field is there.
one more is MED.
Sorry. Yeah, multi-execution description.
Mm,
Sorry. Yeah.
for outgoing, there is local preference and wait, and for incoming, is path
Yes, then
prepend MED. And which what is the protocol number? What which protocol will BGP will use?
yeah, TCP port 179.
179. Okay. And what are the BGP messages that we have?
Four messages like open,
Hmm.
keep alive, update, and notification.
Okay. When notification message will you can see notification message.
So while keep alive, like BCP system is established and keep alive is being established.
Mm-hmm.
So whenever the like BGP routes are updated,
Mm-hmm.
in the updated message while updating, the routers will be advertised in the update message. So while this in routes is advertising, if you see any error in the
Mm-hmm.
update message, the notification message will be sent, and
Mm-hmm.
it will move to the ideal state again.
Okay. Okay, Raju, I'm done with the interview. Okay, so I will share the feedback with Satya. He will contact you. Okay.
Okay, bro.
Yeah.
Thank you.
Okay. Thanks. Thanks for joining. Have a good day. Bye.
Thank you. Thank you. Thank you. Thank you.